So now I'm going to explain example 2. The manufacturer of new fiberglass tire claimed that the average lifetime of a tire will be 40 in 1000 miles. To verify the claim of a sample of 10 tires tested with their lifetime, and we found the following result. Test the manufacturer claim at 5% level of significance. So this is a question regarding hypothesis testing. The first step, as I told you before, that you need to mention what is your null hypothesis and what is your alternative hypothesis. So your null hypothesis, you're claiming that the average lifetime of a tire is 40. So your mu is equal to 40. The alternative hypothesis, we will take the opposing, which is that your mu is not equal to 40. Why we are not taking greater or less than? Because nowhere is mentioned that we want to claim whether the mean lifetime is greater than 40 or it is less than 40. So we will take the unequal sign in the alternative hypothesis. So we have two opposing hypotheses, and now we have to test that whether our null hypothesis is correct or it is not. So we might make a wrong decision and we might reject the null hypothesis and actually it is correct. So we have alpha % of chance that we might make a wrong decision. So what is our alpha here? Our alpha is given that 5% level of significance. So that is step 2. You decide what is your level of significance for this test. Even if it is not mentioned in your problem what is the level of significance, you can use 5% because most of the studies they use 5% as level of significance. Step 3, you have to decide which distribution this problem follows. So as you see that there's nowhere it's mentioned about the population standard deviation. So your population standard deviation is unknown. It's only given to you the population mean, which is 40, which you need to test. Nowhere else it's mentioned about the population standard deviation. Only your data is given. You have 10 data. So what we have to do here when we have to decide about our distribution, we will say that the first condition is not there. There is no population standard deviation. So we can't use normal distribution. So your population standard deviation is unknown, so it is one of this distribution you use. Your sample size is not bigger than or equal to 30. So you can't say that we will follow normal distribution approximation. So it means that you will follow the last one because your sample size is 10, which is less than 30. In that case, you have to use t distribution. So that is the last one. So your test statistic will be t, and this is the formula. Your x bar is sample mean. Your mu, the mu is population mean. S is the sample variance, and n is the sample size. How to compute x bar and s, small sample variance, sample standard deviation, we will see that later on. Now step number 4, find the critical value from the table. So how do we find usually the critical value or the table value? First of all, we decide whether it's one-sided test or two-sided test. Since in the alternative hypothesis you're testing not equal, it means you're testing two-tail or two-sided. So we will be here in the two-tail. Alpha is 5%, so 0.05. So we are here. Now which value you have to use? As I told you before, for normal distribution we use the last row where z is given. Now the remaining things in the table, they gives you the t value. Now which t value we use, it is based on the degree of freedom. when your sample size is 10, the degree of freedom you have is 10 minus 9, which is 10 minus 1, which is 9. So the degree of freedom in this problem is n minus 1, which is 10 minus 1, which is 9. So 9, alpha is 0.05 to tell. It leads you to this result, which is 2.262. Now this is your table value. So 2.262, it's your table value at alpha 5%, which means at confidence level of 95%. Step number 5, you have to compute the test statistic or the calculated value of your t. So we have our data, we have 10 data. To compute the average or the sample mean, we have to sum all the x's and divide by n. So the summation is 375 divided by 10, which is n, gives you 37.5. Sample variance or S square, you compute it by subtracting each x from the sample mean and then squaring. So each x you subtract it from the sample mean, which is 37.5, and then you square. So you do for all your data, then you sum all this difference. So when you take the sum of the difference between your data to the sample mean, it gives you 70.5. You divide that by n minus 1. So this is degree of freedom, n minus 1, which is 9 now. Why we don't use n in the sample variance? Because we already lost 1 degree of freedom when you compute the sample mean, okay? So we divide here by 9. For sample variance, we use n minus 1. So we get 7.83. Now that is sample variance, S squared. What about sample standard deviation? Take the square root of this, it gives you 2.799. Now using this x bar and s, calculate the test statistic or the calculated value. So substitute here, and then it will give you 2.82. Now we will make decision in step 6. So based on the table value and the calculated value, we can observe that the calculated value is bigger than the table value. So as I mentioned before in the procedure, that when the calculated value is bigger than the table value, then you have to reject the null hypothesis, whatever is your null hypothesis. So what was our null hypothesis? Our null hypothesis was that the mean lifetime of the tire is 40. So we are rejecting that. So when you reject that, it means you are accepting the alternative, the opposing hypothesis. So what is written in opposing hypothesis? In opposing hypothesis, or H1, it's written that your mu is not equal to 40. I'll just show you. So when you reject this, it means you are accepting the alternative hypothesis. So it means you have enough evidence to claim that the mean carton weight is different from 2 kilograms. Okay, so that is